So step 3, now we are going to move on to the DNA synthesis. So the presence of the RNA primer over here provides a free 3' hydroxyl end at this region. So this allows the DNA polymerase tree to add DNA nucleotides to this short RNA primer. Okay, so it will add the DNA nucleotide, which is the red color. The hydrogen bonds will be formed between the complementary bases. After that, okay, when you see the template at this region, so the elongation process also occurs from the 5' to the 3' end. So when you look at the template, this is the 5' end, okay, and then this is the 3' end. So as I said to you earlier, okay, elongation must occur from the 5' end to the 3' end, which refers to the newly synthesized DNA strand. So that means it will be opposite from the template. So that means your 5' end will be here and your 3' end will be here. So the synthesis of the new strand will be from a replication fork away to the outside, yeah? Away from the replication forks. Okay, so the primase is needed here since there is nothing over here. So it will keep on adding RNA nucleotides. Okay, add on the complementary RNA nucleotides. And then, when you have a 3' end over here, so the DNA polymerase will add the DNA nucleotides. Okay, and the hydrogen bonds will form between the complementary bases. So now, the step will be repeated, okay, in which the helicase will keep on unwinding the DNA in this region. Okay, so what will happen is actually this part will become supercoiling, and then topoisomerase will actually bind here to reduce the strain of this strand, and then this double strand over here will be separated, and the single strand binding protein will bind to this region to avoid them from rejoining. So the process will be repeated over and over again. So in this region, the replication continues towards the replication fork. Okay, since it has already a free 3' end hydroxyl end over here. So the DNA polymerase tree doesn't have any problem to add the DNA nucleotides to this side, and it just keeps on adding until it reaches the replication fork. So it will add the complementary nitrogenous bases. Okay, and hydrogen bonds will be formed. But when you look at this strand, so there is no 3' end over here. Okay, that means this is the 5' end of RNA primer. That means the primase is needed once again to create the RNA primer, and then only then you have a free 3' end region for the DNA polymerase to work on. That means the synthesis of RNA primer is needed at this part. So primase will catalyze the formation of the RNA primer. And once you have that 3' end over here, so then only the DNA polymerase will add the DNA nucleotides to elongate further. But, okay, in this region, you can see that the DNA polymerase just add the nucleotide, but it will not join the first strand with the second strand over here. There will be a fragments formed. So this is one fragment, and then this is another fragment.